Right, hey everybody, let's go ahead and get started. First, I guess I should say I hope everybody had a great night or day so far. And mine has been pretty good. It's gotten cold again here, so I had to go cover up some more sensitive of my plants. It's really strange to have so many cold nights here in Houston where I live. Usually it's still pretty hot even during January, but we've actually gotten down into the low 20s, which is really strange. But anyway, let's start with some programming. Okay, so yesterday we were updating the hexagon terrain mesh to use a new margin system, which will help simplify the way cliffs work, and also I think they'll make them look better. Let's see how far we got. Okay, so we have the right pattern here. I colored these like the rainbow so I could see which point was going where. And I can see it looks pretty good. So obviously we need to make it so the colors are what they're actually supposed to be, and then we need to make them slope up, which both of those will be pretty easy to do. Of course, slopes we have, like we could just attach them right there, but we can't do that because we have to take into account blocks that are in the middle, like always. Still, it won't be too difficult. Alright, so let's see. So I guess let's do the colors first, because that's going to be pretty simple. I will just assume there's... well, actually, maybe we should... Well, doing the colors and elevations kind of goes hand in hand. Yeah, so, okay. I want to start with this. Let's ignore the triangles for now, I think. Because they'll be slightly different. So we're going to need to get surface for each. Okay, so okay, so I guess we already have the surface for my position, but not for the neighbor. Should probably make a better helper function here so that I can set the layer without having to copy this over, but I guess it's not a huge deal. So surface, get layer, column, and row. Now the layer here will match up what it's supposed to be, and I think that might be enough to do it for the most part. Right out of range. Oh, right. So the issue here is that if the neighbor technically is out of bounds of the grid, then it has no surface, so we'd want it to just be the same as my position. Oh. I guess we will need a helper function for this. We get it margin neighbor position. We'll want to pass at my position and also side. So if position, or wait, neighbor position is valid, then we would be able to find the surface. Otherwise we'll just return what we had before, because it'll by definition have the same layer as the X position. And I guess I can go ahead and fix the triangles now, because we have this nice little function here, so I can just do the same thing. Alright. Okay, and yeah, now we can see that they all match up already. So this is kind of the look that we're going to go for. Obviously we need to fix the colors, but at least I don't see any holes in the geometry. Now we can see that no matter what, every point in these triangles only touches one hexagon, so we don't have to worry about averaging or anything. Alright, happy with that. Okay, so let's start doing the colors. I think I'll just ignore slopes for now. But actually, the get neighbor color is also a lot simpler now. So get margin neighbor color. Do my position and neighbor, and it should return a color actually. So I think I can use this, except we'll be able to simplify it a bit. Oh, it's complaining because that wasn't uncommented. I'll rename this. Okay, so here, get the surface. Oh, we already have this. Surface should already be given to us, so we don't have to do that. And if the layers are the same, then we want to get the neighbor's color. If the layer, my position is greater, oh, that doesn't even matter anymore, does it? Yeah, because we don't really have cliffs. So yeah, we always just want to get the neighbor's color. The only problem we would have is if, again, we have to deal with different layers. Let's just build up from this. Yeah, if the neighbor is valid, then we want the neighbor's color, otherwise we want our own color. Okay, so the color. My color is just get prototype, column, row, and layer. And neighbor color is get margin neighbor color. Okay, so here we just need to match up corner and then the neighbor. So where it's corner is just ours, and then where it says neighbor corner is the neighbor color. That's pretty simple. And then here we gotta do the same thing. But this would be called other color. In its corner. Okay, yeah, so we actually have to use all three. Then other color. And then my color, and then the neighbor color. If we really wanted to, we could just pull this in here because we only use it once, which I guess I'll do. Right? Oh. So yeah, it looks perfect actually. Got it in game. Yeah, it looks pretty nice. I mean, very simple, but can't complain. Alright. Don't see any issues. Everything seems to be blending fine. Yeah, I'm happy with it. Okay. So the only thing we have left to do is on this cliff, the block that's below this top one is actually stone, so it should be gray up to here. And then it would change to this top block. Although I'm trying to think, would that make us have an issue that we had before? I need to try to figure out how. I want the triangles all fit together at this with that idea in mind. So I mean, I guess the easiest would be we just draw a line across here, but then there is this point that touches a bunch of different hexagons. Well, no, these points just touch this one hexagon, so it's not that bad. How do I want to handle this in a way that actually looks good? I guess the other option is that you would only see the tile that's on the top, but that doesn't seem like the best. I feel like this is something that I need to solve now before I move on because it's going to affect the rest of the game. So again, if we drew here, this point touches this one. But also, that'll just look weird too if it's just like flat. No. So, like if I wanted the stone to show on the bottom half, how would I make that cleanly blend into everything else? And still have it be visible. I guess one thing I could do is like have a kind of terrace where this stops and then there's a small flat area. but I don't know if there'll be that much room for that, and if we get to really high cliffs it will start to look strange. Okay, so I think I'm going to think about it for a while. Let's do another little side project until we get back to that. The color blending and slopes. So these are kind of related, and then we need to decide how to make blocks below the surface visible on cliffs. I don't really think they should be totally covered. Well, I guess whatever I decide is going to have a gameplay ramification, so this is how I want to do it. It might just look best if it just stays like this, so that the surface block has complete control over the sides. Yeah, so I might do it like that, so yeah, we'll see. I mean, I guess if I ever want to change it, it's not like I can't later on once we've gotten some more complicated stuff on the top done. Okay, but anyway, so I guess we're done with this for now. So what I have here on the to-do is I want to extract some common code between the graphics and collision meshes. Okay, let's close. Basically, like, both of them need to know the surface elevation and then every corner. That's what this storage does. Yeah, figure corners. And this code, well, it doesn't take into account margins yet. It hasn't been updated. Let's actually look how that, or see how that looks. Where is the collision mesh? Oh, yeah, so it still has the flat sides, which we definitely don't want, because we want it to follow the slope sides more. Also, the points go out all the way to the middle of the margin, which is kind of how I want it to be, but not on this part. But since so many points are needed for both, I think it'd be a good idea to try and like have an in-between class that kind of analyzes the structure of the map and calculates a bunch of this math, and that way when these mesh generators come, all they have to do is look at that data that's already calculated and build all the triangles that are needed. Another thing is that also, like, our graphics right now are pretty pointy, but if somebody wanted to make a mod style that had like smooth rounded edges, the best way to do that would just be to have a completely different terrain mesh generator that has shared vertices like we do for the collision mesh. So I think we just need something completely different to do that, and I would like to at least have possibility to add support for a smooth terrain mesh. So this will just add another what's the word? Just leave that door open. So we had this blueprint builder class before. I guess I could reuse it. And the reason this didn't work is because it just didn't have useful information, really. So what we really want here is something like, this should be a vector 3. corner points. Another nice thing about this is that in the graphics mesh generator we calculate points for hexagons several times, but with this blueprint thing we'll only need to calculate them once for every cell, and so that will save quite a bit of time, I think. Okay, we don't need this stuff. Really need to be a list either, but I guess to make it reusable. And the 6 always. So we had different builder. I need this, it just needs the board. Don't really know if we need this surface class either because I'm going to put all of that elevation data into this blueprint. Okay, so it just creates a new one, so yeah, let's just make it an array, I guess. Oh, I did that wrong. Cells equals print cell and the total size of the board, so we could just board. Oh, that's 1 for every layer actually. Or one cell is the same number as the layer size. Okay, now here it's going each column and each row. I guess that's fine. Not super needed at this point, but okay, so we have the layer, cell, I think I will just pull out the get layer. Calculate some stuff that we already know. Oh, we actually haven't calculated the number of layers, but it doesn't need a cache. I'm just going to not go by column and layer just for simplicity, so int x equals 0, x less than print cells length and blueprint cells x equals cell. A cell dot layer equals get layer index. Actually, I can't spell index tonight. Okay, do I need to? Yeah, I guess I don't really have to add in a color, but I should put in the prototype ID. I'll rename this to there. I don't even know if I need to do that because it's really easy to get the prototype. It's just look into the board. Yeah, it'd just be the surface prototype anyway. Okay, so I know we don't need any of that, but we do need to calculate the points, which I can grab from here. Okay, and I need to know the center, which I can get from here. I guess I need to do the hex position. Did I put that into the cell? Maybe. And it's... I need to try and think of what data would be useful to have pre-calculated, and what data is just superfluous. I could do something like that, and that will have the surface layer in it as well. Okay, so next cell dot surface block. Oh, and I definitely should have the center position. Cell dot point this. Oh, position from cell, I don't have that. Okay, so now we just need the points, which is cell dot corner points equals cell center point plus. Oh, and then I have to loop, so for int like 0 less than 6. So what doesn't I like about this? Oh right, I need to put the array index. Okay. Now in the graphics mesh, if in generate we pass the blueprint, like we used to. Kinda funny that we're going back to it, but okay, we don't need the surface variable anymore. So here we'd have the cell index and also the, oh no, the mesh blueprint is a variable. Don't need this stuff, but we still need the block prototype. Oh no. Did I just put it in the mesh blueprint? I guess it is just useful. Except, okay, no, I don't really want to do that because, like, this is only the surface prototype. But I guess that's right now that's all we'll need. Okay, so I guess I'll do it for now. this. All old. And now we could even update it. Want to do that? Because the face of the hexagon will always be flat, so technically we could create these triangles so that they share vertices and take a bit of load off of the shader so that there's a few less vertexes. And like in the future we will add some height variation, so I don't know what would be better. Well, I guess right now we might as well. It's not going to be that difficult, except this add triangle has a different doesn't work based on the vertex index. Guess we could just not use it and we can add the triangles into the list ourselves. Let's see, how would I do this for each side? Well, first we want to add the point to the vertexes. Oh, so get the blueprint cell. Blueprint cells index. Okay, and we've got to add the center, of course. Point. Vertice RV. Let's do colors afterwards, I guess. Oh no. Add cell surface prototype color. And here we would just add vertex for each side. Points high. Then we want to add a triangle for each. So I guess we need to know this x start vert is vertices count. So again, a triangle is just you add the index of the 3 vertices that make up that triangle. So we want to get the hex start vertice, which is the center, and then we want to add this point as well as the point clockwise. Pretty easy to do. So hex start vertice plus I, triangles add hex start vert plus I plus 1, but then of course we've got to modulo by 6, so it will go around. Oh, and then we also have to add 1 so that we go past the center. Because the center is just hex start vertice, and so the first point is hex start vertice plus 1. That looks good. And then we gotta add a color for this. Okay, so here you can use the same logic, I think. And anything on the margin we would not want to share vertice because it could be sloped. We could like have them share vertice if it's flat, but I'm not going to worry about that because I don't think it's worth it. Is cell surface or position. Wait, now I forget if this was column or row originally. Okay, so cell surface block. My cell equals blueprint cells cell index. And the one thing I don't like about this is that we have to like keep converting from positions to indexes to get the neighbors, and there's not really a reason. Or wait, no, there is, because we need to know if it's out of bounds or not. So never mind. Of course, we could always pre-calculate the neighbor indexes for each hexagon. I kind of like that idea, actually. Do the neighbor cells, and we could just have it be -1 if this can't be an integer. Oh no, it can't. We just need to know how many cells there are. Oh wait, no, that's silly me. It's always 6 because it can only have at most 6 neighbors. So yeah, it will be -1 if it has no neighbor. Okay, and so how we would tell is next position neighbor position equals cell surface block plus what is it? Hex position, axis, vectors, and then we side. And if neighbor position is valid E on the board, which basically means it ignores the surface, then the cell neighbor cell would equal, oh no, it'd be the neighbor position dot column plus row times the row size. Oh, of course, I always forget to add the index there. Otherwise, we'll set it to -1. Yeah, this will be really useful because everything needs to know what its neighbors are. That way we won't have to try and figure it out every time. But I still need to know that, I think. And blueprint cell neighbor cell is, well, I won't know that yet actually. Well, I guess if it's, oh yeah, this will be kind of simple. If the neighbor is me, okay, so well, I guess this is still simple. So even if the neighbor, like if the neighbor doesn't exist, then we still need to know, like, theoretically what its points would be for the borders. Not sure the best way to handle that. I think unfortunately we just need to do some calculations for that. So if my cell dot neighbor side less than 0, Basically what we need is the neighbors A and B. And then it's prototype, so we can get the color and stuff. Sector for A, B, oops, but I spell it like that. And then block prototype, neighbor proto, neighbor A if this is, if the neighbor doesn't exist. So if it does exist, will actually be easier. Well, first we need to get cell. Cell is cells. Like that. This would just be the neighbor cell. Corner points. Copy this. If I remember right, we had big problem, or not a big problem, but it took me a while to figure out what these points should be. Basically what side they were supposed to be. 3. And the prototype. Just the prototype that's in the neighbor cell. Otherwise, you get this information, but we're going to have to calculate it ourselves like we did here. It's a bit of a shame, but I don't know any other way to do it. Unless we like had like fake cells all around it that were just had a null prototype, which would make all these calculations a lot easier, but it would like not match up with the actual board. No, if that'd be really nice if I could do that, but I just don't think it will work. Because I'd have to, like if I did that, I couldn't use the actual board object for anything because it would have a different width and height and everything. But maybe it would be worth it because I wouldn't have to go through this. There would just be a blank neighbor to the side that was air. And then when we would go through the create cell, it would be just a dummy cell, so we would skip it. So how often do I use the board? I think I pretty much only use it for like to get the layer size and everything. Okay, well here I get the prototypes. But we'd have the black block prototypes now, so we don't need that. It might be possible. Here. So if we did that, we'd have to have this public bool is valid. I guess maybe the thing to do is to make the cell indexes not match up exactly with the map, and so we just use this surface block to get information from the board. That actually is the best idea, I think. So, with that in mind, this blueprint builder, we'd actually want to add 2 more rows and then a column on the left and right. That would actually be more than this. And rows is board row size plus 2. And then the columns. So we don't have. Oh wait, columns is the row size plus 2. Then rows is the layer size divided by the row size. So if I wanted to get layers from this, then I guess I could just add it back together, or multiply, I should say. Okay, so if I added the, like if I move these back into each other, then I see it's just layer size plus 2 times board size plus 2. So if you... Oh, that's actually more complicated than I thought. It's something like layer size plus 4 plus some other things. So this is fine. Just trying to get fancy there with my math. Don't need this. And so now we just won't use the board layer size. We'll use our own. Well, this isn't the layers, this is the size of the layers, so this will be cells. Okay, so this position from cell is also not true anymore. Let's just copy this. Everything will be slightly different because we can't use the board to tell us if it's valid or not. Surface block is something like so every cell we need to go based on our number of columns, and then subtract 1 from each, I think. Get the board size for the real board. And the layer we can still use get layer, but let's do this. So int real column is index times the column minus 1. Real row index divided by columns minus 1. So just get layer, real column, row. So if valid. If board is... Wait, that's not how you do it. Do X position, real column, real row. 0 is valid 2D. Then we do this. If it's not valid, then we just return, I don't know, -1 because it has no surface. Oh, I should just return. Yeah, I'll return -1, I think. Yeah, that's an interesting issue, actually. because, say for example, we want the edges to be the same layer as the hexagon that, like in here, we want the edge height to be the same layer as my cell's layer. But I guess that's, but they actually need to be kind of the same as neighbor next to. If they're different heights, that'll be kind of weird. I don't know how we'll handle that. I guess just wait when we get to that point. -1 will be fine. Okay, so center block, still fine. And that's still fine, but of course... Well, technically it will have neighbors, but I don't know if we need to actually deal with them. So if cell... Oh wait, it would be cell surface block is valid on 2D. Then we'd figure out the neighbors, but if the cell is not valid, okay, well this is, the whole point we're doing this is so that every neighbor cell is actually there. But the columns and rows are now not based on the real position, they're based on these fake positions, but all the fake one is just the same thing plus 1. Using R row size, so the number of columns. Okay, but yeah, if this specific cell itself is not valid, then we don't really need to do neighbors. Because it won't be making, like this, nothing should call this create cell on an invalid cell, which would be all the border ones. Okay, so I think this will make everything a lot easier in the long run. So there is a little weirdness at this point. So I still need the cell index here. I could just get it this way. Position. Row. Then we want to get the board index, which is different from the cell index. I really shouldn't call this that. Be, I guess, the lowest block index, and then each one above one layer is just you add the layer size to it, so this is fine. Oh, but this should actually be the highest block index. Oh, no. Yeah, it's the lowest block index, and then we start at the top layer. Okay, so I think this is all good. And now if I go back to the graphics mesh generator, don't need to do this anymore because we'll know the neighbor cell, which makes me very happy. And they'll gonna abbreviate neighbor as nay. Print cells, my cell, neighbor cell, side. Well, that's that. So now my position and neighbor position we know. Centers we know because they're in the blueprint cell. Corners we know. The colors we can get from the prototypes. Okay, now do I want to get fancy and try... Right now all of these quadrants are... They share a vertex, so I guess I could really just... this within the add quad. I guess that kind of makes sense. So it's ABC and color ABC. Then the next one is A B and then vertex B and then it's color A D. Except we don't have to add the vertices again, that's the whole point. Add them like that. So now, of course, these okay, fine. These points are these two triangles will share vertices, so it'll be smooth, but they always should be flat, so it won't make much difference. So it should be ABC, which is that, and then ACD. That, okay. Yeah, so I don't need this anymore, but I'll leave it in case we ever need to revert. Anything uses it. Okay, so now this is my cell, corner points, side. Neighbor A is neighbor cell, corner points, side plus 4, so 6. My cell, wait no, it's the neighbor again. Corner points, side plus 3, mod 6, and now it's back to my cell. Corner points, side plus 1, mod 6. It is a little neater. Okay, so now it says my cell, prototype, color. Color and neighbor again. Okay, so I think that's it. Pretty simple. Now we need to get current cell, other cell. So this is again 1 clockwise, so side plus 1. And it's basically the same except it's just a triangle. Need any of that values, or any of those values I should say. So it's this, the neighbor B, which is the second one. And then the other, which is side plus 5. Other cell. Corner points. My color. Neighbor color. Okay, I just realized one thing. The other prototype will be null. So we'll need to do something there to fix that. Like right here, surface block is fine. Oh, I don't ever get the prototype here, this class yet. So we'll want get prototype. We could just pass the hex position. Okay, so cell dot surface prototype is get prototype. I guess just in here we'll check if it's valid. So valid to be on the board. Otherwise we'll return null. And how will I handle that here? I guess I'll just need to do something like this. Color. My color is my cell. Surface proto color. And neighbor color. So if the neighbor cell surface proto. One fancy thing I've started using in C# is you can do this double question mark, and this is called the null coalescing operator, and what it does is if this is null it will return the value afterwards. So we can do something like this. I wish Unity would hurry up and make an upgrade to the next version of C#, because then you can do something really cool that's like there's this operator, which means only call this if surface prototype is not null, which is very useful. But we can't use that just yet because, as we saw, this version of C# doesn't have that operator. Here we'll do the same thing except with the other cell, and now I need to place the right. So we don't need this. Don't need that. Time to clean up the code here. Don't need any of these. One thing I need to do here is only call create cell if print cells I dot surface block valid on 2D. Okay, so do I ever use the board any other time? Here to check. Oh, this is still fine. Because we care about the actual board index and not the cell index. The cell index should really only be used to get information from the blueprint cell. It doesn't have anything to do, well, it does have stuff to do, but it's not obvious how it's related to the block position. Okay, and the collision mesh generator is kind of, I mean, it still works, but it's going to be all, like, actually, I guess it still works exactly how it is right now, so I won't change anything. Where is it? Brain mesh. going to need current generator. I guess we still need the surface for the collision mesh generator, so I won't delete it yet. I guess I actually should pass the battle. And the actual blueprint. The builder. Build. Then I need to pass that. Okay, so let's see. Hopefully it'll look exactly the same as it did before, but everything's greatly simplified. Not exactly. What's going on here? Like... Okay, well that tells me that something was probably wrong with the way I calculated the cells. One weird thing, or one thing that's different, is that we can see the edges slope downwards. I think that's fine. We might actually... These end of the world cliffs will probably look different later on anyway. Something is wrong here, I guess. Oh. Actually, I bet what's wrong here is that we loop. Yeah, based on the board layer size and not on the number of cells. So we gotta change that. Oh. There we go. Recompiling, I guess. Okay, now it's playing. Okay, good. Now the entire train mesh is there. And it's not noticeable, but it's slightly more efficient because all of the mesh, or all these triangles, share vertices, and also this edge right here shares vertices. So we actually got rid of a lot of extra points that weren't needed. So that's good in the long run. I still haven't quite decided how I want to handle cliffs. I just need to think about it, I'm pretty sure. I think the thing that would look best is if we did like some type of terracing here. But it's just that if there's a really tall mountain, that's not going to look that good. But I guess we just need to experiment with it. And it may be just that in the gameplay you don't need to know what block is underneath, really. Although that does seem a little strange. Alright. Now we need to update the collision mesh generator to work with the blueprint, which I think should be very simple. Yeah, I'm going to copy this over. that anymore, and we'll use private blueprint. Okay, so we still need this storage thing. Where do I generate that? Oh, it's just a list. Okay, so that's fine. Need to figure the corners anymore. Need the layer or the block index. What is this? This is just... Okay, it's integer, so we actually do need to do the bigger corners, but all it does really is grabs points. It's a lot simpler. I don't know if it needs to be a separate thing, because before they were trying to like share vertices with neighbors of the same elevation. But really it wants to try and grab the index of every point on the hexagon, but really nobody else needs to know that anymore because they're going to be internal to the margin. Another option, of course, is to just use the graphics mesh generator as the collision for now. Although that wouldn't really work because the graphics mesh doesn't keep track of the owner of every triangle. So yeah, I don't think I can do that. I was gonna say, because we'd want to come back and definitely have a separate collision mesh later, but right now I wanna keep working on the graphics mesh, but I guess we'll update this quickly. I less than 6 plus. So yeah, nobody else will really need to know these vertices, but the rest of this function will. The other the other cells will only need to know the edge vertices on the margin. And we'll need to like stop halfway into the margin. We could do fancy things to save on triangles if we like moved to the edge of the margin if we're on flat ground, but I don't think I'll do that. Okay. Guess I'll just leave it like this for now. I mean, spending too much time trying to figure out how I want to do it. Storage corner. Do I know how many triangles? Oh, I guess it's just the number of vertices. No, that's not true. Well, actually, yes, it is true because none of these corners will actually touch the outside world, so we don't ever want to share with anybody. So we just do that, and then we want to add a triangle. It's the block index. We can get that easily with a hex. Cell cell is current cells index. Let's change this to cell index with it. And then the block index is just the cell surface block board index. So let's use the same name here, board index. So then we add a triangle. Oh yeah, and we only have to create 4. That's nice. I don't actually add the vertices. Cell corner points I think that's all I have to do. What is this? Again, the neighbors. I guess that's fine, but we could probably do it simpler, like I do in the graphics mesh, where we just pass a side and figure it out. The other ones from that. And unfortunately, none of this is really needed for now because we don't know how we're going to handle multi-block cliffs yet. So I think I will leave most of it commented so we can check back later, but I have a feeling it'll be a lot different anyway. Oh yeah, because this is like flat cliffs, which we definitely won't have, so... So like the graphics mesh, I'll basically just use the same thing, I think. Side and make triangle. Yeah, none of this is going to be very useful, so I'm not going to even worry about saving it. Okay, so we don't really care about the prototype or anything, but we do need to know our neighbors. One interesting thing about the collision mesh is that even for hexagons that are outside the board index, we need to create these corners. Or actually it would be like the margin end. Dot public. Because they'll need to match up with the previous ones. Okay, so one thing before we do that, we need to... Every cell, even if it's on the end, will have this margin end. Other ones that... That's a little confusing. So if a cell is on the border, well, I guess we'll just do this and we can try and fix that later. But like if it's on the border, the collision for every cell is supposed to end like halfway along the margin. So on the border there'd be a certain part that has no collision. I guess it's not really a huge deal, although it is a little strange. We can always fix that. So this will be, let's not call it margin, and this will be margin corner. And yeah, no matter where we are, excuse me, we'll always have a margin corner for every side. We just maybe won't. Oh no, we'll actually always make triangles. Yeah. So all this is not that useful either. So every time we need to figure out if we need to create our own vertice or check the neighbor if it's already created one, but regardless it'd be halfway between the 2 points. Oh wow, it's already 9. Okay, so let's write some comments here. Get neighbor for side margin corner is halfway points. Oh, and actually the margin corners, there's like more because there's 2 points per side, yeah. So that is 12. Where am I? Right here. Storage dot margin corner is 12. Corners are halfway between 2 points. So it's kind of like we did before. Wish I could write it now because I have it pictured exactly how I want to do it, but we're out of time. Yeah, but it's not really that difficult, so we'll probably be able to get it finished quick. I might even do it over the weekend sometime so we can start on something else besides working on these margins and cliffs, which we've been doing all week. Okay, so I did that. This is what I'm doing now. And I'm not going to move this down. It'll just be at some point. I guess we need to figure out better cliffs before we did that, so maybe I'll put that up there. I'm just not sure. The way it works now, I mean, it's fine, but that means that for gameplay purposes, blocks under the surface can never have any impact. Which is maybe fine, but I don't know if we ever wanted to have like monsters ever be able to like climb up a wall or something. Maybe we just disallow that. But again, if we wanted the underground blocks actually have a purpose, how do we display them? Well, maybe I'll have to do some SketchUps or something, but yeah, we just won't worry about it for now, I think. It's just going to take some play testing, I think, to figure out, or some design. But anyway, I guess that's it. We're done for the week. 1 week back to streaming. I'm glad we got quite a bit done, so I'm happy. Although we did waste a little bit of time at the beginning of the week because I started on that flat cliff system that just didn't work. Well, actually, technically I started on that before we left, so it's not completely my fault, but anyway, thanks everybody for coming by. I do appreciate it. I'll be back Monday at the same time around 8:30 Eastern, and we'll start where we left off. If you missed any of the stream or previous one, you want to catch up, I do have a YouTube channel, so you can check them out all there. This will go live probably Monday morning. I also have a Twitter if you'd like to follow. I tweet there when I go live, and of course you can follow me here on Twitch. And feel free to join my Discord channel if you'd like to chat with me over the weekend. And other viewers as well, we'd love to have you there. You can reach any of those by typing exclamation point and then YouTube or Discord into chat, or looking at my channel or video description. And I guess that's it. Hope you all have a great weekend, and I'll see you Monday. Bye-bye.